This first question, a DVD disc has a diameter of 12 centimeters and a rotational period of 0.1 second, is asking about centripetal acceleration. What it gave us is it gave us diameter, but it gave it to us in centimeters. So first thing we need to do is we need to change that into meters. So we know that we have 0.12 meters, but we don't need diameter, we actually need radius. So we need to take this and we need to divide it by 2 because radius is half of a diameter. And we are going to get that our radius is going to be 0.06 meters. The question also said that the rotational period was 0.1 second, but rotational period is just telling us what the period is going to be so that we know that that is our t. This question is asking for centripetal acceleration, which means that what we're looking for is we're looking for A equals v squared over r. We already have our r, but we don't have our v. So first step, we need to get our v, which means we're using the formula from yesterday, and we have 2 pi r over t. So if we put in all of our numbers there, we have 2 pi times 0.6 divided by 0.1 is going to get us a velocity of 3.77 meters per second. Now we have our v and we can put it in over here. So now we're going to put in that we have 3.77 squared, and we have to divide that by our radius, which is 0.6, and we'll get an answer of 23.69 meters per second squared, which we need to change to 23.7 meters per second squared for significant digits. The second question, determine the magnitude of the centripetal force exerted by the rim of a dragster's wheel on a 45 kilogram tire with a 0.4 meter radius, which is rotating at 30 meters per second. It's asking for the centripetal force. We have the mass and we have the velocity. So what we need to be doing is we need to be doing that our centripetal force is going to be equal to our mass times our velocity squared divided by our radius. This question, it's already given us all of our variables. We have 45 kilograms. We're going to multiply that by our velocity squared, and our velocity in this case is 30. We're going to divide that by our radius, and our radius, I actually never wrote it down over here, but our radius is 0.48 meters. So here we're going to put 0.48 meters. And we are going to get that our answer is 84375 newtons, and we have to put that into significant digits, which means we want 8.44 times 10 to the, we're moving this 1, 2, 3, 4 times 10 to the 4 newtons. This last question is asking for maximum speed, and I actually think in the last couple I said velocity and I should have said speed. So it's asking for maximum speed, it's given us mass, it's given us radius, and it's given us mu, which means from our dynamics unit, what we know is that we know that our force of friction is going to be equal to mu times our Fn. So that's what we're going to have to do with our mu. So we can calculate that right off the bat. We can say, okay, we know that Fn, we know that it's going to be mg. So we know that we can take 0.660 times our mass, which is 1500, times gravity, which is going to be 9.81. And we know that that is going to be 8,829 newtons. So in this case, like we talked about, we know that if this car is turning around a corner, and we have our car here, this is my blue arrow, then as our car is driving, the only thing that is keeping it in its turn so that it's not continuing to go in a straight line is the centripetal force. However, that is also our friction. So we know that our force of friction is going to be equal to our centripetal force. So with that, we can say that this 8,829 is also equal to our Fc. We also know that our Fc is going to be equal to mv squared over r. If we multiply both sides by r, we can get rid of r. And if we divide both sides by m, we can get rid of m, which means we're left with our Fc over m equals v squared. So I've just put in my numbers here. I have 40 times 8,829 divided by 1,500, and if I take the square root of that, it is going to equal our speed. So our speed in this case is going to be 15.3 meters per second.